Oh, hi. I want to talk with you about the first derivative test. And I think it's the first derivative test, not the first derivative test. What we're working on when we are doing the first derivative test, our objective is to find minima and maxima, or we want to find optima for a function f. I started to write my f early. Okay, so I want to find optima for f of x. Okay, as we found earlier, these are at critical points and boundary points. But it's also true, crit point does not imply optimum. Crit point does not imply optima. So what we want to do is be able to know, okay, well, if critical point doesn't imply optima, then how do I take critical points and decide whether there are optima there? So this hole in our knowledge right here, that just because you have a critical point doesn't mean you have an optimum. We can supplement that with additional knowledge about the first derivative, and then we can classify as an optimum or not an optimum. Okay. This right here leads to the first derivative test. And it's the first derivative test because what we're going to do is we're going to use f prime. Okay, so what I want to do is let C be a critical point, which I just write as crit point. So let's C be a critical point. Then if f prime of x goes from negative to positive across C, or goes from positive to negative across C, then we have an optimum. F has optima at C. So I think the right thing to do as far as getting this picture across is to draw a picture. And then I'll summarize the derivative test for you again after we're done with that. Okay, so let's draw a picture of a function, and let's put some critical points at those. Let's put some critical points and examine the nature of those critical points. Okay, so here's a curve. Let's give it one of those. Let's give it one of those. Let's give it one of those. And let's give it one of those. So I'm going to put dots at the critical, or stars. Let's do stars at the critical point. Okay. And I think I should number these also. So let's call that one number 1, 2, 3, 4, and 5. Let's draw an axis. That's the x-axis. And let's put marks down where these critical points are. Okay. So this is critical point 1, 2, 3, 4, 5. Infinity is over here. Infinity is over there. What I want to do is I want to describe the SIGN sign of f prime on these intervals. We'll always go from left to right. The function is increasing. F is increasing. This is my function f. F is increasing here. Increasing means the derivative is positive. It's decreasing here. The derivative is negative. It's increasing here, positive. derivative is decreasing. Or, sorry, the function is decreasing, so the derivative is negative. Here the function is increasing, positive. Function is increasing, positive. So let's examine what's going on with these various critical points. Critical point 1, derivative does not exist at critical point 1, but the derivative goes from positive on the left to negative on the right. As we pass across it, we experience a sign change. It goes from increasing to decreasing. We're going up, and then we're going down, right? It's the top of an elevator, or not an elevator, a roller coaster, right? So we're going up, and then we're going to go down, which means that we had a max at this place right here. So I've got a max. Here, it was going down and then up, so we have a min. Here we're going up and then down, we have a max. Here we're going down and then up, so we have a min. And here we're going up, and then we keep going up, so neither. There's no optimum there. Okay. So what that lets us do is it lets us revise this statement. So this just said, if it changes sign, then there's an optimum. But we can do even better than that. If we know the way the sign is changing, based on what we just saw right here, we know whether it's a min or a max. So we can say not just I know I have an optimum, but I know it's a min or a max. So if my number line, so here's f prime of x, if it goes from positive across C to negative, this is max. If f prime of x goes from negative to positive, then I have a minimum. If f prime of x goes from positive to positive, then I don't have one. And if prime of x goes from negative to negative, then I don't have one either. So if there's a sign change, you have a min or a max. If it's increasing and then decreasing, then you have a max. If it's decreasing, then increasing. Min, no sign change, no optimum whatsoever. Okay? If you were asked to do an optimization problem, the first thing you should do is find the critical points. And then this is an option of several for how you can classify those critical points as having an optimum at that location or not. And I think that it's pretty straightforward to do this. Let me be really explicit in terms of my suggestion for a tactic for how to do these problems. So this isn't just a concept video. I want to give you tactics for how to think about these things. Okay, so we're doing an optimization problem. I think the first thing that you should do is look at a plot of the curve. I think drawing a picture is the most powerful thing you can possibly do. That says optimization. So we're doing an optimization problem. I think step 0 is draw a picture. Okay? I think you should draw a picture because that's going to be the thing that hints to you as whether you're doing things right as you go along. I think the next thing that you should do is find the critical points. Okay? And so that's, I want to take f prime at x and set it equal to 0 and solve. I also want to find where is f prime at x undefined. And those occur at places like where a denominator equals 0, or possibly have something like natural log of 0, which is undefined. So things like that, okay? So we're going to draw a picture. We're going to find our critical points. And then I think you should scatter crit points on a number line. And then I think you should, 3, evaluate f prime of x, f prime of x, on convenient points inside those intervals. Okay, so I'm going to choose whatever nice, convenient values, and I'm going to plug in my, this convenient value right here, and I'm going to find what f prime of x is equal to. And I know f prime could only change SIGN sign at these crit points, and so I just want to classify it as positive or negative for each of these intervals. And then I can just read off min, max, min, max, min, max. What do I have going on, right? Is it going plus to minus? Okay, cool, max. Is it going minus to plus? Okay, cool, min. And so I think this is a really good way to quickly classify your points using the first derivative test. There is a second derivative test where instead of having to take the first derivative and evaluate it twice like this, you can take the second derivative and evaluate it once. Which may be easier. Maybe it's harder. I don't know, because it depends on the problem. And people also tend to like the different derivative tests depending on, I don't know, their life experiences and how their mind works. So that'll be a subject for another video. Thank you so much for your attention today as we talk through the first derivative test for classifying crit points as having or not having optima, that is to say minima or maxima. I appreciate you, and I hope that you're well. Toodaloo!